for questions at this point in time before we get into some examples. We totally need to do examples. Anybody, anything? All right, let's do some examples then. Here we go. New slide. Okay, so let's do ordered pairs first. For example, let's say that my set A is 1, 2, 3, 4, 5, and my set B is little a, little b, little c, little d. If I were doing this in class, I'd probably draw sailboats and flowers, etc., but I'm not quite as good at drawing them on the computer whiteboard at this point in time, so we're just going to go with boring letters and numbers, sorry. Here's my function f. I'm going to do this by listing out all the ordered pairs. So 1 comma a, 2 comma a, 3 comma b, 4 comma a, 5 comma d. So that's my function f. I'm listing out all the ordered pairs. 1 comma a, 2 comma a, 3 comma b, 4 comma a, 5 comma d. All right, everybody good? We've got all those ordered pairs. 1a, 2a, 3b, 4a, 5d. First of all, is this a function? I gave you 2 rules that we needed to satisfy in order for this to be a function, and those are back like 2 slides. So, is this a function? First of all, are all of my ordered pairs coming from the cross product A cross B? Is the first component of all of my ordered pairs from A is the second component of all of my ordered pairs from B? Give me a thumbs up or thumbs down. Does it satisfy the first rule? All of these coming from A cross B. Yes, I'm getting thumbs up. Yes, okay. So 1 is that F is a subset of A cross B. Yes, this is good. Secondly, that's kind of sort of 1, but not exactly. That's sort of in the definition. Maybe we'll call that 0 because that's sort of hidden in the definition before we get to 1 and 2. So we'll call that 0 instead of 1. Can I make a 0 and circle it? Sort of. Okay, secondly, for all A living in capital A, there exists some B living in capital B so that A comma B lives in F. For all A living in capital A, there exists some B living in capital B so that A comma B lives in F. This is a fancy way of saying every element from A shows up in an ordered pair. That's what this is basically saying. Every element from A shows up in an ordered pair. Every element from A shows up in an ordered pair. That's the fancy way of saying this. For all, right? That goes with an every. Every element from A shows up in an ordered pair. Do we like this one? Thumbs up, thumbs down. Yes, no? What do we have for this one? Grant, question before we do thumbs up, thumbs down.
In the beginning, when you chose little f in the ordered pairs, aren't there more ordered pairs like when you do the cross product? How did you choose just those?
Totally arbitrary. So this is the absolutely arbitrary decision that I am making for this first function. There are absolutely more ordered pairs in the cross product. There are going to be 20 of them altogether, right? 5 from the first set, 4 from the second set. You multiply together to get 20. Remember, a function is a subset of the ordered product. These are the ones that I happen to pick. Okay. All right, thumbs up, thumbs down. Every element from A shows up in an ordered pair. Yes, no, what do we got? Yes, yes, we're getting thumbs up. People are nodding. Yes, okay, cool, this is good. Secondly, if A, B1 and A, B2 are in F, then B1 equals B2. So if A B1 and A B2 are in F, then B1 equals B2. That was my second requirement for a function. Do I have, and again, another way to say this is if the first component is the same, then the second component is the same. So if the first component is the same, then the second component is also the same. That's saying this one in words. If the first component is the same, that's the A here, right? If I've got an A in the first component for both, then the second component is the same. So B1 has to equal B2. If the first component is the same, then the second component is the same. Okay, do I have any first components that are the same? Go back and look at your function F up here. Do I have any first components that are the same? Yes, no, no. Okay, so this is an if-then statement. What happens when the hypothesis is false? We've done this. When the hypothesis is false, the whole statement is true. Yes, I'm saying keep them all true. Remember, that's vacuously true or true by default. Okay, so yes, this one's fine. Yes, we are good. This is a function. Yes, everybody's happy. All right, since this is a function, let's identify domain, codomain, range. So my domain is easy. That's just the set A, or I can say 1, 2, 3, 4, 5. No problem there. Domain is easy. Codomain is also easy. So my codomain in this case is the set B. That's A, B, C, D. Easy. Domain and codomain are both very, very easy. No problems there. Range is the harder one. So range is all actual outputs. Not all possible outputs, but all actual outputs. So my range in this case is A. That's from my first ordered pair. A again, I won't list it twice. We don't usually list things twice. So A again, B, my range is B gonna go in there. A yet again, I won't list it again, and then D. So my range is A, B, D in this case. A, B, D. Do we see my range is A, B, D? Why C is not in my range? Yes, we're good, we're happy? Everybody good? Okay, cool. Let's do another example. So let's do this one. For example, let's keep A and B the same. So A is once again 1, 2, 3, 4, 5. B is A, B, C, D. Same sets as before. So we've got A, B, C, D. Here's my function F in this case, set of ordered pairs. 1A, 1B, 2C, 3D, 4E. 1A, 1B, 2C, 3D, 4E. Range, domain, codomain, all that fun stuff here. 1A, 1B, 2C, 3D, 4E. All right. Everybody's got the ordered pairs? No, you're still writing. 1A, 1B, 2C, 3D, 4E. I'm going to go back a slide. I want to make this go away. 1A, 1B, 2C, 3D, 4E. Okay, I think you're done writing. Here's what I'm going to do. I'm going to put you into breakout rooms. What I want you to do is decide if this is a function. And normally, if you got to know, you could stop, right? That would be fine. But I want you to answer all three of these. Is it true that F is a subset of A cross B? Is this first one true? Every element from A shows up in an ordered pair. Is the second one true? If the first component is the same, then the second component is also the same. And if you answer no to these, you got to give me a counterexample. All right? So 3 things that I want you to answer in breakout rooms. Is F a subset of A cross B? Do I have every element from A showing up in an ordered pair? And if the first component is the same, then the second component is also the same. Are we good? Everybody understand what I'm asking you to do on each of these? I'm going to open some breakout rooms. Figure out who you want to be your spokesperson for my breakout room also. I'm going to, let's do guys and girls. We'll do guys and girls today. Why not? All right. Okay, they should be open. Take a couple minutes. You should have an invite. Go and talk about those 3 things.